course on structural design and drawing of foundation and retaining walls. In the last class, we discussed about what is the foundation, what is the footing, and what are the type of foundations, and which scenarios we are going to use those type of foundation. In this class, we are going to discuss about what are the IS 456 recommendation for design of the footings, that is combined footings, because this this chapter deals with design of combined footing, strap footing and raft footings. We are not going to discuss about the design of isolated footings. So if you look at the first criteria, so this is the basic criteria. Footing must be designed to transfer the load safely to the soil without causing excessive settlement, shear failure or bearing capacity failure. What does that means? The footing function is it has to transfer the load from the substructure, that is from the columns, to the soil without allowing soil to too much settlement, or the soil can't be fail in the bearing. That means that load has to be less than the soil bearing capacity of the soil. That is the basic criteria of designing of the footing. In that way, we have to select the area of the footing. That is the basic funda behind the calculating the area of the footing. And the second one is the minimum depth of the foundation should be 500 mm, that is 0.5 meters below the natural ground level. Even though we found the good rocky surface, we have to keep the foundation at least 0.5 meters from the ground level. And third one is, so because these are the combined footings, that combined footings are prone for the bending. If you look at the critical section for the bending in the short direction, that is widthwise direction, it is at the face of the column. So in the shorter direction, footing will act as a cantilever beam having sagging moment. But in the longer direction, that is in the length of the combined footing, at the middle portion is the critical part of the footings, that is that will subject it to the hugging moment, which we can see in the solving problems. So minimum cover for the foundation is 50 mm, so that we can ensure the durability of the foundation, because the soil has different alkalis, acids. So to protect the reinforcement in the foundation, we have to provide the minimum cover of 50 mm. So if you look at the next conditions, there are we need to check after the design of the foundation. We need to check for shear. There are two type of shears. One is one-way shear, that we can call it as bending shear. The other shear is two-way shear, that we can call it as a punching shear. That means the column can punch into the foundation. So which is very punching shear is very crucial for selecting the depth of the foundation, and the one-way shear is very crucial to select the longitudinal reinforcement at the cantilever portion of the combined foundation. If you look at the diagram, this is the diagram which is showing the two-way shear, that is punching shear. The critical section for the two-way shear is from the face of the column, it is d by 2, that is depth of foundation by 2. So if you look at the area of that one, total area of that block is depth of width of the column or length of the column plus depth of the foundation. So we have to calculate the area based upon the dotted line section of the foundation. So we can calculate the shear force by dividing the load by area of this section. So when it comes to the one-way shear, the critical section is at a distance of d from the face of the column. So we usually do this one-way shear check or two-way shear check for heavy columns, that if two columns are supported by a combined footing and one column is having more load, that is if two columns are supported by combined footing, if one column, just assume one column is supported by one column is transferring 500 newtons and other column is transferring 700 newtons. So we have to do these checks for 700 Newton column, because if it is pass for the heavy column, then straight away it is going to be safe for lighter column also. The same we have put in the wording also. For one-way shear, the governing section is at the distance d from the face of the column, and for punching shear, the governing section is along the perimeter at the distance d by 2 from the face of the column. Here we are going to use the area as a perimeter into depth of the column. Here we are going to use the area as breadth and length from the center of the center of the column, that is a by 2 plus d into b. We are going to use this area as governing area for one-way shear, and we are going to use this total area for governing as a governing area for the punching shear. So with this I am going to end this topic, and as I already told you, the prerequisites for this course are RCC, reinforced concrete design. So for that, by assuming that you are gone through the RCC in third year or second year, so I am providing this assignment. Derive the expression of area of steel for flexure, that is AST, in terms of moment of resistance. So I am going to give you a hint. So you already know moment of inertia moment of resistance equal to 0.75 y AST into d minus 0.42 xu. So you already Fi is constant. I already told you I need AST in terms of moment of resistance. So you no need to omit the moment of resistance. So AST you have to find. So d is the depth of the foundation or depth of the beam, whatever it may be. So you don't, only unknown is xu. So sorry. So replace this xu with Fi and fck. So that is equate the 0.36 fck xu into PD equal to 0.87 Fi AST. So from that find out the xu by d. So in that xu by d, please substitute that in here. So you will find the quadratic equation. Solve the quadratic equation and find me the AST in terms of mu. Please do submit the assignment in stipulated time. Thank you. In the next class, we are going to discuss about the steps to design the combined rectangular footing, so that you can use that same footing in designing of combined trapezoidal footing also. Thank you.